Come light it up, I'm ready to go. Come light it up, come light it up, I'm ready to go. Come light it up,
So I'm Tobias Macy. Folks probably know me as the host of the Data Engineering Podcast, and I've also been running the AI Engineering Podcast to keep track of all the craziness that's happening in that ecosystem. And today I'm talking to Ken Pickering, VP of Engineering at Going, about the application of Iceberg and Trino for managing near real-time data in their data lakehouse architecture. So Ken, thank you for joining me.
Tobias, thank you for having me. Awesome. Let's sync up.
And yeah, so as I understand it, you are building a data lakehouse, you're feeding it with streaming data. Most people who are building that style of architecture are focused on batch. And I'm wondering if you can just start by giving a bit of an overview about the types of data that you're working with, the use cases that it powers at Going, and what the streaming engine is getting you over the batch capability.
Yeah, great question. I think so what we're doing is ingesting a lot of external data from the travel ecosystem. So we integrate with what are called global distribution systems, or GDSs, which are like when you go to a website, you go to Expedia, you go to a variety of kind of travel agency websites and type of search. There are underlying systems that capture that data and actually do the price search for you. So what we do is we get a ton of data from these systems, like pushed to us, and actually all of them handle it a bit differently in terms of like how they send you data. It could be like event driven, like it'd be like they just stream you data, or it could be that they send you a file every hour with tons of data in it. But the system has to be somewhat flexible to accommodate the integration. But what we're doing at Going is actually building like price intelligence and price alerting. We have to ingest these massive streams of data in near real time to be able to actually find good prices and then alert our customers, because airline prices change. And so the longer delay on us being able to inform a customer of something that's happening, any kind of delay could actually mean that they don't get the fare, which is not a great customer experience for them. And what we decided to do is, as we were building this, because it was sort of greenfield for us, is, well, why don't we just also, while we're handling this streaming data, also just stream it in near real time to Iceberg, so we can also query it when it lands, and we can get access to it, which is the thought behind it. So,
for that streaming ingest, what are the technologies that you're relying on, and what are the acceptable latencies that you decided on for the near real time versus the pseudo real time, because you can never actually have true real time?
Yeah, and that was what that we don't need true real time, right? And we don't need near real time. For us is in the order of minutes, which is fine, because sure, there is price volatility in airlines, but it's not that volatile that a minute is actually going to be like a deciding factor. Usually they're changing a couple times a day, so you get some kind of acceptable latency when you get an event. But yeah, we use Confluent. So we look at the Kafka-esque derived products and went with Confluent, and then we use Starburst Galaxy for the streaming ingest, and we also use it for querying our lakehouse. And then we use for modeling and stuff, we use Databricks. But everything is foundationally centered around Iceberg in our data ecosystem.
And Iceberg as a table format has been gaining a lot of popularity, but most of that activity has been over the last 6 months to a year, where before that it was a bit of a nascent technology. There's been a lot of evolution of other table formats. I know that Hoodie in particular was focused on that streaming use case. I'm curious if you can talk to your selection process for deciding what table format to go with, what query engine to go with, and how you landed where you did.
Yeah, I mean, so we're streaming right now about a gigabyte a second, but we're going to be over time probably streaming more than that because we're integrating other providers. And so that lands about uncompressed about 50 petabytes. And so picking the storage form, 50 petabytes annually, right? So it's picking the storage format was significant for us because of the processing costs that would be required to move table formats. And so as sort of building this greenfield, we looked at the current kind of current landscape of format technologies and really saw where the industry was going with Iceberg. And we thought, okay, because for me, right, we're a bootstrap company, we're a startup, it's 20 something engineers, 24 engineers. like we don't have a lot of resources to actually change a lot of these decisions after the fact. And so for us, it was like, where is the market going? And actually what lets us commoditize compute most effectively? Where are the vendors going? What's the ecosystem doing? There was so much movement around Iceberg as we were making this decision that it was pretty clear for us, because like at the end of the day, like I'm using Galaxy today, but I'm also using Databricks, which also has now an Iceberg connection after their acquisition of Tabula, right? Snowflake, I could use Snowflake. And so it's like, it gives us a ton of optionality on the consumption. And so for me, that was really, if we're going to land like in a specific format, that made the most sense to me at the time. So.
And you mentioned that when you're landing the data, it's uncompressed. I'm curious if you can talk to what the format is underlying. Are you using Parquet, Avro, JSON, and some of the ways that you're dealing with downstream processing to get better I/O performance as well as flexibility as far as other compute needs, particularly as you start to explore machine learning if you're not already?
Yeah. I mean, we're using Parquet under the covers. That seemed to be the most logical choice at the time, and that's what we're using. I would say a lot of it, because we're streaming, we deal with small files a moderate amount, so having some hygiene around compaction and, like, I'd say generalized data maintenance. I think there are things we're looking at in terms of more advanced aggregation, like because it's a large data set, are there better aggregations we can provide? And so it's kind of rolling up tables or rolling up data and actually copying is something we're looking at. But then it's I think it's definitely like optimization. So it's mostly around the hygiene of the data lake layer and how we're optimizing for that. I'd say like one of the things we do too is because airline data is really messy when it comes in. It's like massively like nested JSON formats, and it takes a ton of compute to unwind it. And so it's like landing that in the right format and the right normalized format has been a big part of the effort. And actually doing that in a cost-effective way without like melting our face off as we're trying to process these different kinds of structures has been an adventure. Because it's just like at that scale, like where cost, like cost per transaction sort of matters when you multiply it out by the volume that we're doing. And so that's been a big part of it. We haven't, I'd say on the ML side, we haven't really run into, because we're doing a lot of batch modeling, we haven't run into any kind of real-time ML challenges with Iceberg. I mean, I imagine we'll have to embrace that at some point and think about how we're handling like feature tables and those sorts of things down the road. But right now, most of our modeling is batch processing, and so we haven't really had to be too inventive around that.
Given that you're working with airlines, I imagine that once you integrate with a particular source, the schema is fairly stable. Obviously, there's going to be variability across different providers. I'm wondering if you can talk to some of the challenges that you have around that normalization aspect of figuring out what is the least common denominator with room for flexibility to be able to address some of the peculiarities of different sources.
Yeah, I mean, we don't delete anything. I think that's the first step. Like in data, we don't, but we leverage the cloud effectively for that. We use Glacier extensively for a lot of the raw data we capture, and it's pretty cost effective to do that there. I think what we try to do is understand, I'd say, what data we're using today and what data we might use tomorrow, like what is significant data. And so we did some initial analysis before we kind of landed on a specific schema, because in general too, airline data, even though it might be slightly different formats, the fields are pretty normalized because it's a pretty normalized ecosystem. Like everything has fare classes and things that it comes with, and there's a price and there's an origin and a destination and a duration, and and so for us it was like really narrowing down on the domain knowledge of what data was relevant, and then normalizing based on that and landing based on that. But also, like, we acknowledge that we might have messed up and have to backfill. We've had to do one backfill already of like, all right, let's go back to the archive and populate this new value and try not to do this again. But I think that's how we're typically handling it. So it's just trying to forecast what we'll need.
You mentioned that one of the applications of this data is being able to do price alerts that you're sending out to your customers. I'm wondering if you can talk to some of the other data consumption use cases, and in particular, the latencies that you're able to achieve with Trino as that query engine, given that you're constantly feeding new data into it, and maybe speak a little bit to the size of cluster that you have to use to be able to get the latencies that you're willing to accept.
Yeah. So I think we do some amount of filtration up front. You can like in general dump prices because like they can be exorbitant, and so you can call results pretty quickly. So you don't have to do something like score them. But we do score. But the way we try to structure data pipelines is progressive pipelines that serve a function. In that, like, okay, is this a good deal? Yes or no. If it's not, archive it. Is it a good deal? Okay, elevate it to further analysis. So we'll score it. We'll say, okay, this is a fifth percentile deal, and understand who that is relevant for. But then also like look at how it's conforming to model and do further prediction on that deal to determine if this is a route we should keep an eye on because it might be even more interesting in a week, for instance, right? And so it's like trying to understand how to work with these data points in progressive pipelines is sort of how we work with it today. Yeah.
One of the benefits of using a lakehouse architecture is that you're not constrained to SQL as the only interface. And so it gives you the
Yeah.
optionality of being able to use things like Jupyter Notebooks or be able to ingest that data. You mentioned they're using Databricks. So I know that
Yeah.
there are some uh, graph modules that it allows for being able to, in the case of travel, do something like route prediction. And I'm wondering if you can talk to some of the ways that that lakehouse architecture is giving you the flexibility that you need to be able to use that underlying data across multiple modalities.
Yeah, I mean, and that's one of the main reasons we did. So we did a Snowflake migration. Like we were Snowflake before I started, and we are not Snowflake anymore. Part of that was volume, part of that was ecosystem for me. In that, like, I like optionality and tooling. And so one of the reasons for Iceberg is that optionality and tooling and just the wide support on things we can do. So our data science team is definitely using Jupyter notebooks, and they're using a lot of, and we'll use some of the Databricks predefined modeling to kind of narrow on things. But like being able to read directly from Iceberg into that platform is great. It's a huge, like, as I sort of mentioned, we're like a bootstrap team. So any kind of time savings on like trying to compress time to value for us is a win. And so like that's what we do on the other side. I mean, we're doing more of the traditional SQL. So we power Galaxy with we power QuickSight. We're moving to QuickSight with Galaxy. That's partially because of the whole Amazon Q thing. Like we're going through a data democratization effort here on like how we actually try to open data up to more like non-technical users. And it's still early for that kind of technology, but at the end of the day, like that's where we want our industry to go, is like, all right, well, anybody at our company can query data effectively and like through whatever technology is effective and appropriate for them. And so, yeah, I mean, on the Galaxy's been good because we can actually fine tune a lot of our clusters and scaling effectively. Like we'll run bigger clusters for analytics jobs, run, small. The streaming clusters are not that big actually. We don't use like big clusters for that. So our larger clusters are more devoted to analytics. But like part of the great thing about about the SaaS platform is it's arbitrarily easy for me to make a new cluster, right? Like I don't have to manage it. Like it's not the old Trino days where I'm like literally physically managing and scaling different clusters, right? Like for me, it's actually amazing to be able to be like, oh, what? Like we'll just spin up a new cluster and set the parameters, and now and it's ready to go in minutes. Because I mean that's general sassification, but I mean for me it's a massive lift on being able to actually like keep engineers focused on what matters. So yeah.
In terms of that time to value, there's also the question of just the discoverability of the data, understanding what it is, what its semantics are, how could I actually
Yeah.
use it appropriately. To that end, I know that Galaxy has a data products capability where you can actually publish certain sets of tables and wrap it in some sort of a documentation and to help portray what the semantics are. I'm curious if you're using that or what your overall approach is to data discovery, managing data products, signaling which tables are ready for consumption, which ones are in the works and not quite complete yet.
Yeah, I'm laughing because like it's a conversation I'm having like this week with everybody because it's just like um data accuracy. So that's outside of the data lake, right? Like your like data accuracy, like the number of times I get like, is this dashboard right? Like, and I get sent a link to a dashboard and I have to look at it and figure out if it's right or not. And so like data management, data lineage, data documentation is a massive problem and challenge at every place I've been to, and something that we have to solve. And so like for me, the thing I am looking heavily into like into how we document data products effectively, and I'm playing with the Galaxy functionality on that right now. I like the lineage functionality a lot more because it lets me actually show people where tables are derived from. Because like, in a consumer app, there's transactional data that we know is correct. Like somebody made a credit card payment. It is in Stripe. We have the money in our bank account. Like I know that happened, right? Like that is fairly consistent data. And then there's the data we collect from like our MarTech tools that might be 20% inaccurate, right? And so like trying to balance like, okay, this data is directional and you shouldn't have a ton of confidence in it outside of directionality versus we know this data is absolutely correct because there was a transaction in a database on our end and we actually captured this data ourselves, right? And so like, but being able to tell people that is really hard. It's like a massive pain like to do because like, but the underlying challenges of that are pretty clear. It's that we make decisions based on incomplete or wrong data. Like as a company, we can operate on incomplete or bad data. And I actually said this in a Slack thread last night. I would rather we just went on gut than bad data, right? I'd rather we just like, because at least I'm not justifying it with like incomplete data that I'm thinking is complete data, because that's even more dangerous. I think that's a personal take, but I believe that is wildly more dangerous. So
Absolutely. And in that question of data quality, rapid time to value, being able to enable experimentation, are you, and if so, how are you taking advantage of the versioning capabilities that Iceberg offers for being able to do things like set up a new version of a table to see, is this doing what I want it to do, maybe diff it against the currently active version, and then either roll forward or roll back with those changes?
yeah, we just started playing it because, like I said, this is sort of greenfield. And so as we played with flight models, as we started changes on our underlying flight model table, we started messing with that. I like it. It's cool. I love time warp. I love time travel. Like time travel is amazing. I think it's, and we're not at the phase where it's like arduous to support time travel because we haven't run into like issues with too many snapshots. But like in general, like I think that is, I think it's really essential for quality and management, especially because, I think outside of data management, like a rogue job, like wiping out data or injecting bad data is also like, it hasn't happened yet, but it's always something we have to guard against, as and it's like, and I would say like it's prohibitive to do replicas, right? It's prohibitive to do replicas at our scale, and so like versioning helps with some of the quality concerns, and like and time travel and snapshotting definitely helps with like the other form of quality of like injecting like a bad data into the ecosystem. So.
One of the other things that I love about Iceberg is the fact that, as you said, it is so widely supported. One of
Yeah.
those interfaces is DuckDB, which has been gaining a lot of ground, which is very useful for developer experience. And I'm wondering, what are some of the ways that you're using that flexibility and tooling and wide support for being able to reduce the time and effort required to do development validation, make sure that you're actually able to use production data to make sure that the changes you're making make sense versus just, here, let me take a little snapshot of data that's not actually representative, and just some of the ways that Iceberg and Trino enable you to shorten that inner loop of development and experimentation before you even push to a production system.
Yeah, I think that breadth of support and open source support, and I love what the DuckDB guys have done too. Like, I think that breadth of support is a huge factor in why you want to adopt this ecosystem in the first place. In that, like, it lets developers customize their experience in such a way that we can actually, I think, build quality and sustainable platforms under the covers without reinventing the wheel every time, and I think that like in terms of data technologies, I'd say that's one of the most important aspects of it. I would say the shallow copy stuff is the stuff that I missed about Snowflake, like moving from Snowflake is their kind of shallow copy mechanism. Like I think for me, like these kinds of functionalities also make it a lot easier for me to justify a move from a technology like that. We're not playing with Duck internally today. And I think like the ecosystem on our end is ever maturing, so we're still kind of heavy like RDS and Elastic outside of like the Iceberg ecosystem, but yeah.
And going back to that end user experience, how much of Trino is actually in that critical path of a user going to the site, looking at pricing options and setting up a price alert versus how much of that is you're using Trino to bulk process that data and then build a cached version that is what the end user actually interacts with?
Yeah, right now it's pretty partitioned, but because it's an app, like it's not partitioned. And I got let me try to explain it because it's like an app architecture, right? Like there is the app experience itself, which is sort of structured kind of like a stereotypical web app or there's usually like a fast database or Elasticsearch or something that's like powering the experience and you're loading into that from a variety of sources, right? Like, so you think of Elasticsearch as kind of like a search cache. So the app has fast response on the search cache, but the cache itself is populated like with stuff that's coming in from Tree and other sources. And the other part is the notification. I'd say notifications in app, which is like all driven entirely by our data and data science ecosystem, is how we get people in the app, and it's how we drive like what a good price is and what the alert is. Because most of the time people aren't just sitting on their app scrolling for a good flight deal. Like they set up their preferences, they set up their home airport, they set up like what routes they're interested in. And then when we find a price, we send them a push. And so like that process drives intake into the app and is just as important as the app experience itself, because that's where the convenience comes in. That's where the value of the app comes in. People want a seamless experience. Like, here's a great price, book your flight. You click the notification, it takes you to a link that shows you what the flight is. You push book this flight, you're done, right? And so like, I would say like the consumer experience itself is designed to be like as fast as humanly possible. And so we're not driving a lot of that with our underlying data ecosystem today. I mean, all of our analytics and all of our ML and all of our notification framework, whatever, is all predicated on that. So,
And for being able to populate the bulk data that you're working with into those Elasticsearch and RDS environments, I know that one of the benefits of Trino is that it's a federated query engine that allows you
yeah.
to read and write to multiple different sources. Are you taking advantage of that at all for being able to actually write that processed data directly into the RDS or the Elasticache?
Yeah, we are. I mean, one of it goes both ways for me. And that's one of the reasons I really like Trino. Is like I love I think it's as much as I would love all of our data being in a data lake, it never is, and it's not the only data technology we'll utilize as a company. And so like streamlining the ways to either ingest data into like a dashboard or export it from a system to another, and being able to rely on a single system for that and not rely on like tons of programmatic logic, but actually set up SQL jobs to do that is a lot more maintainable from my perspective. I'd say it like democratizes things to a certain extent because analysts can do it, engineers can do it. Like the technology is not so like overwhelming that it requires you to know like a scripting language or something like that. And so outside of SQL itself. And so like that's been a pretty big differentiator for me on why Trino. I think it's I think in engineering, a lot of us just associate it with just a data lakehouse engine or an engine over object storage. But I think it can be leveraged a lot more effectively than I've seen people typically deploy it in those capacities. So that you're asking that question, it's a good functionality.
Absolutely. And another capability that I know is in the works is some of the file loading for being able to say, I've got arbitrary files in object storage. I want Trino to just go ahead and bring that into the lake for me. Is that something that you're keeping an eye on and planning to use, or does Kafka do all the work that you need to do on that front?
Yeah, we're using Kafka for all that today. I'm a big fan of like a message brokerage or queuing as an interface mechanism, because I believe in like multiple distributed services as well. And so I'm trying to normalize a lot of our data transfer on Kafka across different service domains, so I can have other services leveraging that effectively. Um, you know, it remains to be seen if we stay hardcore Kafka or if we use one of the ancillary technologies, I think, because there's been more advancement in that space as well. But for now, that's what we're pushing on. So, yeah.
No, absolutely. Um, and as you continue to invest in your current technology stack, you start to mature the architecture, you get everybody else in the company up to speed on what it does, how to use it. What are some of the forward-looking technologies or patterns or maybe improvements in data modeling that you're planning to work on to improve and capitalize on this overall investment?
Yeah, I mean, so one of the things I like about the setup we have, like Confluent, Galaxy, some DBT, right? Like I think uh, Iceberg S3, but like one of the things I like about I'd say the front side of the tech stack is that like once we establish a pattern, I can have other people reproduce that pattern in a way that doesn't require tons and tons and tons of specialized knowledge or spinning up new infrastructure. For me, I believe in much in the way I believe in democratizing data. I believe in democratizing engineering, and that like if someone wants to add a new data source into our overall ecosystem, that shouldn't be like a big deal. Like that shouldn't be like something that is like a huge amount of engineering investment or require like a data engineering team to focus on it. Like, I believe that most great engineering these days is built on top of data in some capacity. Like AI and ML are so pervasive, and there's everything, the giant hype train on generative AI. But like at the end of the day, like it all fundamentally is coming down to like data you're ingesting and data you're utilizing. And so I think modern engineering organizations have to embrace those concepts and actually figure out how you get engineers to be comfortable with actually, well, no, this is just how we pipe data. This is how we land data. This is how we query data. Like, and on the AI ML side, this is how we write models. This is how we actually like serve model to production. And so coming up with predefined patterns for that was one of the first things I tried to establish it going in so we could innovate on top of that. And so like you put like the 3-6 months of effort initially into like sketching out your architecture and landing those things, but then all of a sudden it's arbitrarily easy to start adding new sources. And it's actually, it's actually arbitrarily easy for people to play with models and iterate on models in production. And Databricks makes it easy to serve up on the back end of like serving a model in production and takes care of that load for you. So you don't have a complex service orchestration framework you're doing to test out a new model. So I think it's great. And I am, it's one of those things that I think can exponentially or at least geometrically grow your engineering efficiency, because like the more data you can ingest and the easier it is to deploy services, like once you get the initial load out of the way and people get comfortable with the tooling, like it becomes straightforward to do. So
Absolutely. And I think, too, one of the benefits of the Lakehouse as an architecture, as we've been saying, is its flexibility and also the fact that it has so many different avenues for growth. One of the ones that I'm personally keeping an eye on is the introduction of vector indexing and vector storage to the Lake architecture, particularly in the Lance file format. And I know that there is some ongoing work to integrate Lance and LanceDB into the Trino query engine. So I'm excited to see how that starts to play out and starts to collapse the stack even further as far as the AI and ML ecosystem working alongside traditional data engineering and having everything in one place.
I would love to see that, because I mean, I would be remiss in saying that we're not looking at generative AI as a business, right? I think every business is looking at generative AI, but like, in terms of like content generation or personalization of content, or, I mean, it's something that I think, that I would love to see as an integrated ecosystem, because it's definitely the Wild West on the generative AI side right now, and that like there isn't a lot of best practices or best patterns, and so I love to see Trino enter the fray there. And be able to continue normalizing on that stack. So.
Absolutely. Well, that brings us to the end of our conversation for today. So definitely appreciate the time you've taken to, appreciate the time you've taken to talk to me and share your journey of building a data lakehouse architecture on Trino and Iceberg. It's always interesting to hear people's different takes, the reasons that they chose the different technologies that they did, and how they're leveraging it. So appreciate that time.